Thanks. Yeah, we have two panelists here, Eric Van Dusen and Mary, and Carl hopefully is joining online from Berkeley. And I think we're kicking off with a recorded part from Carl. So if you could get that queued up, and then I'll set up out here for the rest of the presentations.
Hello, I'm Carl Boettiger, and I'm an associate professor at UC Berkeley in the Department of Environmental Science, Policy, and Management. And I'm pleased to be able to share with you today what's been going on in our classrooms. So this talk is titled Jupyter AI and Open Language Models in Large Science Classes. I teach a class called SBM 157, Data Science for Global Change Ecology. The course has about 122 students this past fall. And the premise of the class is quite simple. I aim to put students into groups in active learning model, and we spend our time going from paper to paper trying to reproduce key results of global change stories: climate change, global fisheries collapse, and increased mass extinctions of species. In each exercise, we learn to interact with different types of data, tabular data, relational data, spatial data, through computers. My course draws from a mixture of students, maybe 2/3 at the time have a background in biosciences, and this is their first or maybe second time they're seeing code and programming in a classroom setting at Berkeley, and a third or so are coming from a more computational or data science background, computer science or data science major or something similar, but they have several semesters of programming, so have quite a diverse background in expertise coming in. We really try to lean into an active learning model where they are learning by doing, they're interacting with real data on real world problems, and we spend most of our time working in groups trying to solve those issues. So this semester was different. Previously, my course is focused on teaching practices in coding, and now students have access to chatbots that can already perform most of the exercises of our introductory coding classes pretty accurately. Am I preparing students for a future where they have language models? First, I wanted to know if this was an opportunity. Could we go further and faster by being able to bring these language models into the classroom? They no longer need to wait for me to explain some of the basics when they can ask their language model how to do these things, and can even turn to the language model for help debugging specific issues or questions that they have. Of course, this also poses plenty of challenges. As an ecology class, one of the first things we would have to ask are, what about the environmental implications of these tools? What about the ethical implications of these tools, both into their learning and the backgrounds in which these tools have come? And are there ways to make these tools safe and reliable, both for the kinds of answers we're getting back out of them and the educational experience I'm giving students in the classroom? So how do we go about this? Well, my first challenge was what it was going to take to be able to bring these into the classroom and experiment with these tools. I applied for a NAIR grant on a whim over the summer, was able to get awarded to the NRP platform, which I'd never heard of, and I actually think I wrote back to NAIR and said, I'm not sure I can do this, can you switch me to a different platform? But curiosity got the better of me, and I actually logged into the NRP system and just tried to stand up a system for the class, and just was blown away with how much we could do and what we'd be able to accomplish. And it just kept on getting better and better. So the first thing, my course is taught on a Jupyter Hub platform. We use Jupyter Hub through a system we call the Data Hubs at UC Berkeley, in basically all of our large computing classes. So that was going to be a familiar environment. But now I needed to be able to stand that up on NRP. So I needed to specify how we would do that, reading the documentation, bringing in GPUs, something we obviously couldn't do with our existing data hubs. We can just say, I need a hub that has a GPU. I can have that for each individual student. Amazing. So we just learn copying and pasting the documentation. There's a Kubernetes Helm chart. I can specify the resources I need and stand it up, and it just works. I can specify the entire software environment I need for the course as we start to explore new and different packages for emerging things coming out of Cloud Native Geospatial or the Jupyter AI system that we'll be looking at in a moment. I can just drop the latest versions right into my YAML, and a Docker file is pre-built into an image is available for my students. They arrive at Jupyter Hub, they just go to our Nautilus URL, and they can drop right into a pre-built image for the class. We can go and explore a bit more. We can even have them bring their own images when we get a bit deeper in. As soon as they're in Jupyter, they have the familiar environment set up and ready to go, but with this added feature in the lower left-hand corner of an AI assistant. This is talking to a language model that is being backed on NRP and opens the door to some of these new challenges we're trying to explore. All right, so that's the infrastructure side. Some of the challenges I mentioned before, students bring up as soon as you tell them as well that you are not forbidding LLMs, but in fact expecting them to use it. They're some of the first to raise some of these challenges with you. And we had a great chance discussing some of these throughout the course. So students concerned about their own data privacy, is this everything they're doing going to the OpenAI company? They're worried about potential of the energy footprint that would be creating, and other ethical concerns that run the gambit from the copyright on the training data to labor practices to potential biases of the data. How do we address these challenges? One of the goals of our class is getting people to step back out from the technology and, to quote Langdon Winter here, not viewing the impact of computers as something that kind of comes from the sky and impacts society, but recognizing that the computer itself was developed in a social context, and not all of those contexts are the same. What does that mean for us? We pivoted from being able to say that language models are a providence of ChatGPT and OpenAI to actually open local models that we can control the privacy of the students' data, that they're not being sent to an external company, that we can use small models to do many of the requirements that we're using, a lot smaller energy footprints, and so on. So here, the model that we've been using for several of the tasks we're exploring are the Llama 3 language model hosted on the NRP platform, and we were able to get support thanks to the fantastic team at NRP for text embedding models to be built in there as well, which help us explore some interactions with specific documents on the student's own computer, rather than just whatever the language model has read in its own training. And we'll show that in a moment. We were also able to start exploring the CO2 footprint involved in these models. So initially, all the students were spinning up instances with their own GPU there. We could use tools like CodeCarbon and try to watch the CO2 footprints that these much smaller models have. And it's not nearly as dramatic as what's been reported on the very big ones. But we were able to go one better and realize that rather than having every student work with an individual GPU, thanks to the support from the NRP team, we could also access these language models over the centralized NRP server through the Light LLM instance, and therefore avoid needing different GPU for every single student. So once this was working, this also opened the door to more models for us to explore, including researcher-developed models like this one here from UC Berkeley called the Gorilla model, aimed explicitly at function calling and so forth. So we had chance to explore newer models coming out that are all open weights models and be hosted directly on the NRP platform through the same Kubernetes setup. All right, challenges with respect to this. So bringing LLMs in the classroom, we quickly realized that many of them don't actually know the most recent tools and methods that we're trying to teach. For instance, one example from our course, provide Python code to plot all buildings in NYC in an interactive map. Llama 3 helpfully tells us that this task is impossible. However, using text embedding, we're able to point the language model directly at the documentation for the package leaf map, which I'm trying to teach, using the commands in the Jupyter AI system, learn and ask. Once we do this, try again, and in one line, I ask it the same questions, and it says, here's how you can make a 3D map using PM tiles, and it gives me code that not only is ready to copy and paste, but actually works, and you can see in the right hand, generates this 3D image using the modern tool sets successfully, because it's able to draw this directly from the documentation using the tools that I'm trying to teach instead of just whatever it can recall. In our final module, we tried to explore further in getting the students to understand different sources of application that they can do in taking language models and building externally facing tools with them. So in this exercise, they were exploring building Streamlit applications that they could point at some of the data sets they had pre-prepared, and the users would ask normal plain language questions like, what is the mean NDVI by grade? And they would have the language model translate that to SQL and execute this as an example of tool calling and bring back the summary results. This is a great way for them to start practicing their nascent skills in SQL, which they had learned earlier in the course, to kind of understand where the language model can sometimes get confused and give an incorrect or translation, and where the sort of the user's question was not the right piece to define that. We also explored more examples with RAG, with being able to provide documents directly to the bot, and then they would sort of have it ask questions and see how well it did in providing the answers compared to what they would do if they read the documents. So in summary, I think we can bring these language models into the class in an active way and demonstrate how we can use them to go farther and ask harder questions rather than standpoint that too many of our classes have needed to rely on and just saying, please don't use generative AI in this course. We are not accepting that. There are challenges in doing this, and we can mitigate many of them with the use of open models. For instance, the concerns about sharing data with the private companies or some of the energy footprint. And we can monitor and get actual data on some of those things when the language model itself is running under our control. I think most importantly, realizing the power of NRP as a collaborative platform where things that I could benefit from suddenly in the classroom, like bringing in research that was being done elsewhere, like the development of the Gorilla model for function calling, and we could stand that up with the help of the NRP team, which I would have never been able to do otherwise. And just kind of realizing that there were these sort of more efficient and effective patterns for being able to deploy some of these things at scale by having access to the NRP community to help me implement and explore some of these possibilities. So having shared hardware, shared software, shared models, we can build on each other's Helm charts, Docker files, Jupyter systems, and invent new and exciting things we can do in the classroom and beyond. Thank you.
Thanks. So, I think, Eric, maybe you can come up next.
It's hard to go after that.
Let me go full screen on this.
All right, I'm Eric from UC Berkeley. Carl's super amazing. I'm going to talk about a thinner, lighter layer that's a little bit higher up. I think maybe we're getting layers now. Like at lunchtime, we had the very top that was like, Jupyter Light, and now maybe there's another layer for instruction, and then Carl's like at a deeper layer. I'm going to talk about three things. One, teaching with Jupyter generally, something I'm super passionate about. And then if I have time and I can talk fast, I'll go to something like he was just talking about, putting small language models in Jupyter.
Can you speak a little closer to the mic?
And then me teaching, I use a lot of generative AI to build curriculum. So starting off point, we have this thing, Nair Classroom. We have national policy. We need to build Nair Classroom. What would I tell somebody who's coming to UC Berkeley who's 17 years old? What would I tell Michael Kratsios? Anybody? Michael Kratsios joke? Office of Science and Technology Policy, doesn't have a PhD, new appointee. So I would say start with Data 8, learn Data 8, learn Python, DS1, then go Data 100, learn some pandas, then go to data engineering, then go to machine learning, then get to PyTorch somewhere with deep learning, and then you would be learning AI. This is like a 4-year plan. This is the newest major and the biggest major at UC Berkeley. There's 1,000 people in it. Data 8 and Data 100, these are some of the biggest classes at UC Berkeley. So we're doing this at scale, and I would say like this is a path to training somebody to do AI. So teaching with Jupyter Notebooks. So these are huge repositories. If anybody's interested, like every notebook that's ever been taught is out there. One way to think about it is there are something like 50 notebooks that are each. They all have giant free textbooks that are stitched out of notebooks. They have, labs, lecture notebooks, projects, really rich ecosystem. And people from around the world can come and stop by and be like, I want to take this, and you can borrow and share. So, Jupyter is like an open source way to build curriculum in classes and share it globally as well. So there's something meta here that like the curriculum itself is run as an open source software project, and that gives us a capacity to be in conversation. UC San Diego, very similar to Data 8 and Data 100, but they have done things differently, a few different packages, quarters instead of semesters, so we can still like borrow and learn from each other as well. UC Berkeley built something 10 years ago for Data 8, Campus Jupyter Hub. What is that like to continue and grow and build curriculum over time? We're something like 4,000 users a week, 10,000 users a semester. It's built so that somebody can come with their Chromebook and, with a $200 computer can get online and use the compute of everything else. I mean, most people in the room are already convinced of this, but I'm just saying like this is something we're learning at scale, doing it 10,000 people a year. It's easy to do, like something you want to do in a classroom. When you see it happen in a classroom, there's 500 people in the classroom. They hit one button. They're all in exactly the same compute in the same container with the same reproducibility. So the idea that it's for reproducible science, but it's working really well for the classroom. We want everybody to have the exact same setup and everything to run perfectly for everyone without thinking about it, right? And we have deployed this at scale in non-STEM classes and humanities classes. There's a lot that you need to do, like hand-holding, like there's a cultural part to do that, but we know that in a pre-coded notebook, we can get non-STEM students to interact with data at least. here's my little graph, different than the scenic graph. And this is how this is running. I would say most of the people in this room are on the administrator side. Like, this is all sort of made visible. This could be what NRP is in the Carl world, or in the world we were talking about before. What I like to think about is the instructor, and we've heard some about this today. Like, how hard is it to get faculty at your university to use this stuff? For me, this is what I do. This is my jam, like professional development of faculty. A lot of the people that I'm actually talking to are math instructors. Like, I'm going to community college and talking to the person who's teaching Stats 1 at community college. And so that's my thing, is like, what's that look like to do the professional development so that a stats faculty, and what I'm competing with is like Pearson, right? Like, we pay and they make everything available and it just works. And like that's like the default that we have to compete with, and be like, you have to use this thing called GitHub and you have to put your files over there. So a lot of the things that people have brought up today as pain points is like, how do we interact with Canvas? How do students submit things? Like, those are all workflows. Those are cultural questions. Those are like, how much computational burden can I put on the students? And then for me, there's also, how much computational burden can I put on the instructor? Like, how much can they rally to learn? Some instructors, early adopters, people have adopted Data 8 at community college for several years now. Some people are able to jump into this space and teach themselves. But now we're like on another part of the tail where we're like, it takes more in-depth and more hand-holding to do it. And how much, over time, do we engineer the whole pathway so it's easier and easier to get that additional instructor on there? And then there's definitely like the tooling on this administrator Kubernetes side that it's making smoother and smoother. And I think you've seen a bunch of evidence, today saying like this Jupyter Hub Kubernetes, like connecting it to things, that's just gotten smoother just in the last couple of years, right? And the possibility of doing this is just, going up. And the number of people that are on our NRP is just going straight up. What can I say? UC Berkeley's doing this at scale for 10 years. We have the biggest majors, 1,000 students in the major. They're doing like Jupyter class after class, hundreds of notebooks, right? We got the biggest class. We're teaching at scale, 1,500 people in a class. Also moving that outside of like the College of Engineering, College of Computing, and like, what is it like to have the stats class and poli-sci and psych and econ, have all those people doing their stats classes in Jupyter as well. And that's like, that's one of my earlier jobs, was just like doing liaison to people out in social science and be like, this is a better way. Like, instead of every single student installs Stata and pays $100, like, let's have this seamless computing extend further. So what we're doing now statewide, trying to get more people on. We're getting CSUs and community colleges on. We're currently running a hub with 500 students per semester at 15 community colleges. We have a new project to expand that, Cal I-Core. We're going to keep going. And I think there's like a huge possibility of how we can work with NRP doing this going forward. One of the projects we want to do with NRP right now that we just asked for an allowance for was this Discovery Hub. We talked about this research-based learning, working with the company or the nonprofit, and the students want some ML compute to do this. So we're trying to set up a hub right now that's like outside of the scope, is what we were calling is like research light, right? So it's outside of the scope of teaching, but it's not like a big research use. But it's like some students want to do an ML model for a project. That's a good place for this NRP collaboration. And then, we're going to keep building out this California infrastructure. And I think one of the things that I heard Frank say, like, very first talk was like, we need the social networks of each other, and like getting to know where are those community college instructors and teachers, and like, there's so much work to do here, but it's like building that, people don't know that we're out there. People don't know that NRP's out there. Like, how do we build out that, that social network of knowing this is, the possibilities to compute here. So this is just a little bit about my previous and ongoing stuff with CloudBank, NSF project for scaling on commercial cloud. Also run through SDSC, and a collaboration with 2i2c. And 2i2c is a nonprofit that has a lot of people from Project Jupyter in it. So that's a way to be close to like what's happening as the Jupyter Hub architecture evolves over time. A lot of this is like onboarding the instructors to the hub. What's the auth used at your campus? What's happening with the autograder? How are you doing that? Like, we know what these pain points are and what's the thing that we need to finesse. But then you can see the numbers of like us expanding the scope and scale of community colleges. And, I think I also loved in the beginning, Frank was like, no, the horizon is like 1 million people, at 1,000 colleges, so it's like, we're like incrementally doing our part, but trying to keep going. All right, I'll try to wrap up. I have some notebooks that I'm working on that's just putting the LLMs in a notebook itself. What is a way to just wrap up the, small, tiny models and give it like RAG, give it few-shot learning. You can go to Hugging Face, download the weights of the model, put it in a shared directory, and then people out teaching can instead of like set up a complicated setting, like just have students in a notebook just touching these open source models. I just want to finish up say like I as an instructor, I'm also a teacher, right? So I teach, I make notebooks every day. This is my favorite one. This was like a really hard project for me. I had the help of GitHub Copilot. I was able to make it in one night. I love teaching this notebook, right? Climate change notebook. Here it is. It's like I'm in GitHub Copilot. If you haven't, Copilot's free for all educators. Make everybody sign up for it. Get faculty to learn it. You're in VS Code. It's auto-completing for you. So the gray part is it's auto-completing. It can auto-complete the code. It can auto-complete the explanatory texts. And I can make stuff as an instructor. I can make awesome curriculum like much faster every day. That's me. Sorry. How do I?
We'll switch gears for now, and I'll start as soon as Mahi gets that up. So I'm going to switch gears on you and talk about training workforce development and our cyber training grant called Cyber Infrastructure Enabled Machine Learning, and where we're training people to do machine learning at scale. So we're kind of not in the LLM space, so just that's amazing work, so don't fall asleep, and I'll try and go fast. So our program is about teaching the skills needed for existing people who already know and have a model to do it at scale, like getting it running on Expanse or even multiple nodes on NRP. And what do they need to do? They've reached the limit of their local compute resources, whatever they might be. And so we've started out just looking at what's required. And then as a result, we've got a training program, and I'll just skip over. One of the aspects of this project is to define the core competencies that people would need to be able to transition from running ML on, their AI model on their laptop to going to multiple nodes on different resources. So you have to understand the basics of parallel computing, what's the hardware that is used for AI computing, learning containers. Those are invaluable for isolating the differences in the computational environment so your model will run. Conda environments and Jupyter notebooks, of course, and then we apply this to the tools needed for scalable machine learning and deep learning. So we've done several summer institutes. We've found that to be a really good tool. It's very small and intimate. We don't have thousands of people. We have a few hundred that have come. We have an annual 4-day event in the summer. We've had 3 or 4 of them now. Actually, we've had 4. And during COVID, we still held our events remotely, and that was really popular. So this is a typical agenda. You can see that we have the scalable introduction. The first day is usually just the basics of HPC. Getting onto Unix, you have to, as a trainer, and a scientist, it's important to me to help facilitate people get onto a Unix cluster that's part of an HPC system. It's just not easy. So we devote some time to that, to make sure they can get on, log on, move their files up, manage their data, and then learn how to submit jobs. So we take them through all of that and hold their hand. Then we show them the concepts needed to run R and Spark and other tools in parallel. So the surveys, people really like this approach. So I'm hoping that others can take this model and start doing more scalable machine learning training. We did reevaluates. I'm going to skip over a lot of that. Yeah, this is an old version of my talk. I did clean this up. So a significant number of our participants liked the training, and over time, I've done post-impact surveys where 80% of them are still using the tools that we taught them, and they're finding still value 3 years out. This year, I'll do another survey. So the idea is to gently bring people into HPC ecosystem, which is really painful. As most of you know, I saw a lot of heads nodding out there. They can use a notebook. We do recommend a container. They can use just regular old code from the command line, but we find the notebooks running in Kubernetes to be really popular. But we don't have LLMs yet, but we did talk about LLM. So we have all of our training material is in a GitHub repository, so it's findable, accessible, the FAIR practices, and we encourage people to contribute, although we haven't had a lot of that. I think that's my quick and dirty, and I've finished on time, as promised. Recommendations: as the tools change, we need to keep looking at scalable machine learning. It is a niche, but it's more and more using a lot of resources. We'll add a session on how to use NRP in the next year. We're in a no-cost extension. Hopefully, we can get extended funding, but we'll see how the climate is. It's important to teach the introductory topics like you've seen here, but we have to support domain experts that need to go to larger scale. And I'm really interested in exploring NRP as part of that. And then if NRP doesn't work, we teach them how to go to Expanse or other resources, sort of like middle tier to upper tier. And that's it. Thank you.
We have time for a couple of questions, I guess. So, anyone?
You're so diverting. Each talk is so different.
Oh, yeah, I know. But maybe I'll ask one general one. In terms of challenges, what do you see going forward, trying to use resources that are also, like Mary said, there's diversity in resources too, right? So what do you see as the main challenges going forward?
To me?
To both of you, I think.
I mean, challenges, like we talked a little bit about this earlier, like supporting things and like, you know, are you if you build an awesome
Can
system,
you use the microphone, please?
Are you responsible for supporting it and being there all the time? And if the homework's due on Friday night, are you responsible? Carl's outside. Yeah, how to keep things sustainable. Like, what if we do go up to like 100, 50 community colleges or 100 community colleges? What would that be like to support that? What is the tool that we can make that will be able to make a few engineers scale? That's my challenge.
Would Carl?
Carl. Carl, you see any challenges?
I see only opportunities. Yeah, great question. So there are lots of challenges, and some of it's just knowing what's out there and being willing to kind of jump in and have a chance to play with some of these things. There are challenges in teaching in language model space as people now face these. There's challenges in sort of learning the infrastructure. I think being able to break these problems down into kind of like bite-sized bits that we can introduce like little bit by little bit into classrooms instead of having to kind of go in with both feet can help. But yeah, lots of challenge.
The challenge I see is getting this propagated so across the country, or at least even across California, people have the ability to do that training for their communities. Like for mine, it's workforce, and they're all over the place and all over the map. They're not all eager, brilliant undergraduates. They're really brilliant postgraduate people trying to do something in their domain. And to me, that challenging getting funding for it. It costs a lot of money to bring them all here. They love to come to San Diego, but we have to have a way to propagate the training at those levels so it's more local for people so they can get to it.
Yeah, I'd love to hear more about that propagation problem. So it seems like, NRP is a nice platform to have this conversation. Everybody is based on shared resources. But at the same time, in a lot of these conversations, we're all reinventing how do we teach these things. We're reinventing what are the examples. It seems to me like there's a big opportunity to pool that stuff, right? And build, like we talked about at lunch, these very, very cheap or free deployable lessons that then others could use from the community as you're describing. I'd love to hear what you think is like, what would be the sort of the most facilitating and or what's the biggest barrier to us starting to organize that?
All right, I'll try first. The biggest barrier would be maybe defining the core competencies that you want to teach, and then how to fund it and organize it remotely, and then building communities that are learning from that. Mm-hmm. And what I mean by that is maybe we need a machine learning NAIR training gateway, right? You know, where people can come, but they still need to talk to people. Mm-hmm. And so building community, there's nothing like in-person communication and that kind of training. So to me, the biggest barrier is how to get the lessons learned portrayed to newbies in a very personal way.
Something better than Stack Overflow.
Yeah, Zoom is okay because we're all kind of used to it now. You know, the first year it was very weird, but you know, I don't know how to do that, but it's a great question and a big challenge that we should try and address.
There's been a really cool, like I've been able to learn a lot. So there's a group that I work with, California Alliance in Data Science Education, and there's community college, CSU, UC people there. And like the community college, math chairs are educating us about what they're dealing with. And the CSU people are there about educating us about they're dealing with. And just like seeing this collaboration, that capacity to like learn from each other, and whether, like UC Berkeley's throwing a curriculum out there, but there's like infrastructural things, and like, I submit a class to my curriculum committee and it takes 2 years till I can offer it, is like one very common one. The thing we're working right now is transfer model curriculum, and the group that approves a transfer model curriculum, like, I think I'm 2 years in, and like transfer model curriculum is something that might happen this year, but only with this like ability to listen to people that are like different stakeholders and participate. I wouldn't have known that like 3 years ago when I started, and now that we're like going down the road, it's like learning from your colleagues as you go.
Great.
I think it's easy for technical challenges to get the like attention and money so often, and the challenges we face are social. I remember being in a room like not that long before applying for NRP and talking to a bunch of folks in HPC centers at like NASA and NOAA and USGS and talking about like what our ideal thing would be. And I feel like we sketched something that was like not that far from like the NRP Nautilus system. And then we all agreed universally like it could never happen, basically for social reasons. So
cool. Thanks, Al. Really appreciate it.
Hi, I'm Jill Park. I'm Jill Park from Claremont Mechanical College. I have a question for Mary, especially for the CIML Summer Institutes. I was wondering, first of all, thank you for sharing your success story. And we also offer summer boot camp on the data manipulation and machine learning and things like that. I was wondering, who are your participants? Do you have any data, like their field, their years in the college or something like that?
Let's see, I could spend about an hour on the demographics. We have about 100 to 200 apply each year. When it's in person, we're getting fewer because of the travel constraints. We have everybody from mostly graduate students, postdocs, and faculty at educational organizations. The majors are all over the map. We have 20 categories: physics, physics and science and engineering, and AI, machine learning, a lot of bioinformatics. So we have just a general application. If you send me an email, I'll find the data or give you the reference to it. We have a publication where we discuss that a little bit more. Our demographics are typically male-dominated. So, again, we have a lot of people that do apply. We have a review committee, 5 to 7 people or more, depending on the number of applications. So we get multiple review criteria and a rating system. So it's pretty comprehensive for looking at who we've got and making sure we're evaluating them appropriately.
Okay. So you're
Good question.
You're mainly targeting those who already have some experience in
You
coding.
have to have, we don't teach the introduction to machine learning. That's being done all over. And what we wanted to do was work with the people who already have an AI model that isn't scaling anymore and it doesn't run on their laptop anymore. Back in the old days when we wrote the proposal in 2021 and 22, that thing called machine learning was just evolving. So that's why we thought, well, let's look at machine learning and try and teach people how to use it. So it was new. But now I had no idea it would explode to the level it's exploded. So we'll reevaluate and reassess, but we didn't know. We just thought we'd teach best practices for people who already have a model, and then they would need to, what made sense at the time was moving up to Expanse or systems that we host in our ecosystem, and now PNRP has evolved to where it's stable and doing good scaling science. So now it makes sense to start evaluating that as well. But it's a big community. Like I said, we get a couple hundred applications a year, each year for the Institute. So it tells me that there's a lot of people out there who aren't undergraduates benefiting from your amazing stuff at Berkeley, but they need to learn and they need to move their models to bigger systems and how to navigate that. And bigger systems also means data, networking. So I think we're running over time, but
Thank you.
I have two questions. So, sorry. The first one is in terms of syllabus and scalability, do you think that the curriculum that you have is able to be prepared and made available for other instructors to teach? That would be a way to scale that potentially much, much broader.
yes, and we all on GitHub. Probably the same for Eric.
Was that a question for me?
No, it was for Mary, sorry.
Okay, well, then, yes, everything is on GitHub and it's downloadable, publicly accessible. And so I hadn't thought about people using it to integrate into curriculum, but it's there and we're happy to work with people interested in that. Definitely.
Same question to Eric.
Yeah, if I didn't make clear, if I didn't make clear in my talk, everything like it's all documented. There's like instructor guides for instructors. We do a professional development in the summer. If you know anybody who wants to come, we teach people to use it. That's all for like the basic intro. You know, once you get to Data 100, the higher courses, that's sort of like on you as an instructor. Like it's all publicly available, but if you want to like learn about it, the stuff's out there as OERs, but it's sort of thought like at the upper division, you're figuring it out. But at the lower, at the intro class, and I was trying to say, like, I spent a lot of time getting lots of community colleges to teach it.
Yeah, that came across very, very clearly through your presentation. I just wasn't sure about Mary's program materials. And the second question I have was in terms of support. You mentioned you're concerned about being so successful with this program that you are having so much demand. And I see the support two-faced. One is helping people with the technology part of the instructors set up the equipment and what have you. And the other part is the curriculum help ensuring that they are teaching effectively, or if they stumble somewhere down the road. And I think of it in terms of if indeed the programs are so successful, I envision if it were my organization, that I would just set up a team, just like I have a application development team or a web team or a network team. I will have an AI support team. And dedicate resources to it. Do you see the same thing happening at Berkeley?
Yeah, I mean, resources are always limited. Human capital is always limited. Like, we have this one awesome engineer who's just so great, but he's a high school teacher who teaches computer science, and he completely gets what it's like to be a teacher. And so he has those both hats, and so he's just really able to help people. And there's some, I want to go back to, like, you just need to meet people where they are, especially when they're a community college math instructor who are just blessed people for doing what they do. But like what their capacity to deal with like a Conda environment is only so much. And so like you really have to, you know, so right now we have like awesome systems set up, but to scale it to get really big, we'd need to think about how to fund more capacity. I mean, what we do for the trainings though is like now you're like, oh, community of practice. Like, hey, you who are teaching Data 8 at El Camino in Santa Barbara, like come to the training meeting and tell the other teachers and have the instructors talk to each other. That's definitely, creating that community over time.
Yeah, I'm sorry. And that's wonderful. And I think you're going to have so many excited people in the community that initially are going to be very eager to support everybody that's pinging them. But over time, they moved on to the next super exciting program or thing that they are working on. And they probably don't want to be the maintenance, support, and operations for these 600 people that are now.
What happened to us at Laney in Oakland is she got made into a dean.
And you definitely don't want to stifle the enthusiasm of those creative people either by pigeonholing them into maintenance and support. Nothing wrong with maintenance and support. Oops.
All right. Thank you so much. And more continued discussion after. And time for the next panel. Thank you. Thanks, Carl.